Welcome back to the channel, and if you're new here, welcome. We are out here talking about how much compost. We're actually at our compost heater. We're talking about how much compost it takes to heat for how long. So this is not a perfect science, but I can relate to everybody what my findings are and how much compost you're gonna need for X amount of time. So if that sounds interesting to you, please consider subscribing to the channel. It really helps us out, and then you get to see all of our videos right away. So let's check the temp on this pile. I tried to show it when I was showing all of this steam up top there. It is just steaming away. We're cooking up above the active level, so we want to keep an eye on it. Got our warm water flowing in here. Very, very nice. Blowing 87 in. I just had this sitting right here, so we were blowing 87.3 degrees into the greenhouse. So I'm literally blowing like almost 90 degrees right up under my butt right now. This thing is definitely warming me up. I am cooking here, so we might end up stepping out of the greenhouse because it's so darn warm right here in this area. And with any amount of sunlight, the sun is waning. It really isn't that strong, but any potential sunlight you get, having a warm environment, a warm insulated greenhouse like this, we're already boosting those temps up, and the sun just does its thing. Both of our window vents had opened up by the time I got home from work, which tells me everything's working properly, everything is still alive, nothing's cooked, it's not too hot in here. It's just too hot for me right now. So I want to state that we took advantage of a little Indian summer. We had a break in temps when we built this pile because we really wanted to get all of this going, and we were waiting for the right time to do it. And temperatures really do affect your compost and the output of your compost heat. So let's relate all of these numbers. I want to talk about cubic yards, and I'm going to relate all of this to compost or wood chips depending on what you're using for a material to compost here. So you've got 1/4 ton of wood chips or compost equaling about a cubic yard. So 1 cubic yard of active compost or active wood chips would create about 1,660 BTUs per hour through the duration of that burn cycle while it's active, coming up to active and then active going down. So those two active points. And that's gonna net you about 2 to 3 weeks of burn time on that pile right there. So let's double that. Let's do a 1/2 ton or 2 cubic yards of compost wood chips. We've got 3,320, and that extends your burn duration to about a month. 3-4 weeks, maybe a little bit more if you're actively turning it and stuff, but that is the whole point of this Jean Pain heater. We have all of that stuff in the middle, and we do not turn it after we set it off. So let's double that 1/2 ton to 1 ton and about 4 cubic yards, and that gives us about 6,640 BTUs per hour being produced during the duration of its burn. And that gives you about a month and a half, potentially longer, depending on what materials and how active it is. So let's double that again for 2 tons or about 8 cubic yards, and that's about 13,200 something BTUs per hour. And sizing it up is going to give you a 2, 3, 4 month burn cycle, potentially 6 months, depending on how well you inoculate it, how fresh the chips are, what kind of compost. All the materials definitely make up the duration of the burn cycle. Grass is going to burn very quickly because it's very, very tiny, very non-dense material. It's going to burn up very quickly. So considering the density of your materials, that's why we went with wood chips, and it was a no-brainer. We got all of these for free. So let's double that again. From 2 to 4 tons, about 16 cubic yards or so, and that's going to be about 33,200 something BTUs per hour being created, and that's going to give you a 6+ month burn cycle. 6 months or better. It's going to burn as long as it's done correctly. So instead of doubling it, this time we're going to go from 4 to 9. So 9 tons is going to break down to about 32 or so cubic yards, and that's going to be about 59,700 BTUs potentially being created per hour. So we have the potential to harvest 60,000 almost BTUs off of just compost. That is like the furnace for your house. That is going to heat a 1,000 square foot home easily. So there is a lot of potential here. It is a no-brainer of why we're doing this and why we're sharing it with everybody. Jumping back to last year, we had about 4 tons. It was between 3 and 4 tons. It was like 13, 14, 15 cubic yards or something. So we just went off of a 4 ton estimate, and we're definitely at the 9 ton ton mark back there, so we have all of the BTUs that we're accounting for. Last year we were producing between 20 and 30,000 BTUs per hour, and it really affected how we built the pile. We leveled it off pretty flat and level last year, and I did not do that. It is hilled up very, very tall, and it's all just going to break down, and that is to account for attrition. It's all just going to break down into the pile, and it's all just going to insulate and keep all that heat right where I want it. Last year the temps did fluctuate a bit, but not a whole lot. I mean, we were between 70 and 90 degrees on our water coming through, and then our air basically dropped down every month. It dropped down a couple degrees, but we never fell below 60. So it started at about 95 and it just slowly kept dropping. And that was because our actual air tube was so close to the outer layer. So I'm always learning and always sharing everything I'm learning by my mistakes. Now, like I was showing, that pile was getting darn hot. We did not throw any nitrogen on there yet. 90% of those wood chips were fresh, so we really don't have to add any nitrogen. I may do a nitrogen dump in the middle of winter if we have a warm spell or a rainy spell where I can throw a bunch of snow, or a sunny spell where I can melt stuff on it, just to get a whole bunch of water onto the pile, and then we can inoculate it again. But I'm confident that this thing is just going to burn through the entire winter and through next summer. So now that this huge monster of a pile is built and the burden is off of my shoulders getting it ready for this winter, I have a ton of stuff to do. Let's just turn the camera around. We've got bunch of life in here. We have just a bunch of potential experiments and a whole bunch of potential periods. So we're going to share a whole lot more on every little part of the greenhouse and all of the heating experiments and everything going forward. We just had to put a ton of time and energy into getting all of this allocated, getting everything prepped, and getting it set. But once I do it, all of that work is well worth it, because this thing just runs on its own the entire winter. These two autonomous systems are just running themselves. We're going to hook up a timer for our water and for some of our fans, just to increase the longevity on those things and get a little bit more cycling on them to be able to push more heat steadily. So this 87-degree space heater is cooking me out of here. We can go check out the temps on this water here real fast. All right, so I'm showing about 90 degrees. The water feels darn warm, and this water doesn't feel too bad. That's like bath water. You could literally take a shower in this water. So this was day 3 here, guys. Just day 3. We've got everything running properly, and now I can focus on everything else I've got to do to get the greenhouse ready. We've got all of our tunnels left to put on the other end, and we're going to connect the polys in the middle, run this space heater over to this to get more heat to where it needs to be, and getting everything situated. So I hope everybody enjoyed this video, this update, and those numbers, because I just wanted to share, because everybody's always asking me how much, how long, and there it is. So basing your numbers off of the information I gave you today is a safe bet. You don't have to worry. They were pretty sound numbers there. Just want to come over and check on these potatoes here. This bed has been very cool to watch grow. Very interesting. I've never grown potatoes inside the greenhouse. So that is a tomato sprout. That's a tomato sprout thriving on this tank's water source. This is sweating, but it's also staying thermally warm overnight, and it's holding all that heat. So we're able to sprout tomatoes. It's amazing to be able to see a tomato sprout when it's freezing every night. That's very inspiring there. So on that note, I will let everybody go until next time, and thank you guys for checking out this video.